All right, get ready, because this deep dive, it feels a little bit like we're in a heist movie. We're
Oh,
talking diamonds, but not the kind you'd see on a necklace or anything.
right.
We're going deep into the world of lab-grown diamonds, and these are the kind that could completely change electronics.
Yeah, it's amazing to think about how lab-grown diamonds are really holding the key to like the next generation of all this technology.
Hmm.
I mean, we're talking about computing,
Yeah.
optics, even sensors.
Really does feel like we're stepping into the future.
Yeah.
But our sources, they hint at a big challenge in creating these diamonds.
Uh-huh.
The way they grow them traditionally involves some really high temperatures,
Yeah.
like way too hot for the electronics that we're trying to aim for.
Yeah, that's right. The intense heat has been a big
Yeah.
problem trying to use diamond to its full potential.
So our mission, should we choose to accept it, is to kind of uncover how they're tackling this heat problem.
Okay.
What are our sources telling us?
Well, researchers at the Princeton Plasma Physics Laboratory,
Okay.
PPPL they call it,
Yeah. PPPL.
and also Princeton University, they're making some really exciting progress in growing diamonds at low temperatures.
PPPL, I have to admit, that doesn't exactly scream diamonds to me.
All right.
What's their role in all of this?
It might surprise you, but PPPL is a major player in advancing microelectronics here in the U.S.
Oh.
Their work is crucial for us to keep up in this really fast-moving field.
Okay, I'm intrigued.
Yeah.
So what makes diamonds so special for electronics in the first place? I mean, it's not like we're going to be making circuits out of grandma's jewelry or anything.
Right, you're right. It's all about the unique properties of diamond.
Okay.
Like the way the crystal is structured,
Yeah.
it can handle incredibly high electrical voltages, and here's the big one. It is exceptionally good at dissipating heat,
Huh.
which is a total game changer for electronics because they tend to get really hot.
So diamond is like this waiting in the wings superhero material, just
Yeah.
waiting for its chance to really show what it can do.
Right.
But how do we get around this whole too hot to handle problem?
Well, that's where this research comes in.
Okay.
They're focusing on something called plasma-enhanced chemical vapor deposition,
Okay.
which basically means they're growing these diamonds at a much lower temperature.
So it's like finding the perfect recipe to grow the diamonds in a cooler environment, but without losing those incredible properties.
Exactly. Now, one of the key ingredients in this whole process is acetylene,
Okay.
which is basically the building block for diamond crystals.
Acetylene, though, doesn't that kind of have a bad reputation? I feel like I mostly hear about it in the context of explosions or something.
Well, in this case, the problem isn't explosions.
Okay.
The problem is soot.
Ah.
Acetylene can actually create soot when they're growing the diamond, and that contaminates the diamond.
Okay.
And that makes them not work as well.
So soot is our unexpected villain in our diamond heist.
Yeah, you could say that.
So how do they get around that?
Well, this is where it gets really interesting.
Okay.
Researchers at PPPL in Princeton, they discovered this critical temperature for acetylene. Above this temperature, it mostly helps to grow the diamond.
Uh-huh.
But below it, you get mostly soot.
Wow. So they found a way to control acetylene's, good side, bad side
Right.
to make it work for them.
Yeah, it's all about control.
So it's not just temperature.
No.
What else factors into this whole process?
Well, it's not just temperature.
Okay.
The concentration of the acetylene and the amount of atomic hydrogen near the diamond surface also matters a lot.
Hydrogen. Now that's an element that I do associate with explosions. Does it actually help grow the diamonds?
Well, it doesn't fuel the growth directly, but it's super important in the process.
Okay.
It helps transform methane into acetylene,
Okay.
and then it acts like a shuttle to transport atomic hydrogen to the diamond surface.
Wow. So we're talking about really fine-tuned control here,
Yeah,
like on an atomic level.
it is.
This is amazing.
Yeah, it's laying the groundwork for incredible advancements in electronics.
Mm.
And it's not just about, the electrical properties.
Yeah.
This research also goes into quantum diamonds.
Yes. Quantum diamonds.
Remember those nitrogen vacancy centers?
Yes, NV centers.
And V centers, yeah.
This is where things get really out there.
This is where it gets really mind-bending.
Yeah.
So in these diamonds, some carbon atoms are replaced with nitrogen atoms.
Okay.
And this creates these NV centers.
Uh-huh.
And these centers, they don't behave like normal physics.
Right.
They operate in the realm of quantum mechanics.
All right. So what does that mean?
It opens up a whole new world of possibilities.
I'm hooked. Tell me more.
Okay, so,
Mm-hmm.
but now we have to figure out how to use these diamonds in practical applications.
Okay. I am officially on the edge of my seat.
All right.
What's standing between us and these diamond-powered technologies of the future?
One of the biggest challenges is figuring out how to protect the power of these quantum diamonds
Okay.
while making them work for electronics.
Okay.
like a really delicate balancing act.
So how do they do that?
Well, remember how we talked about adding hydrogen to the diamond surface?
Right, to make them conductive.
Exactly.
Yeah.
Turns out that adding hydrogen is essential for both electronics and those quantum sensors. But doing it without messing up those precious NV centers
Right.
is a whole other story.
Okay. I'm sensing a new twist in our heist plot.
Yeah.
Why is it so difficult?
Well, for starters, diamond is super inert.
Inert.
It doesn't react easily with other things. And it's also the hardest material we know of.
Right.
So it's incredibly hard to work with.
It's like trying to rewire a bank vault wearing oven mitts.
Yeah, something like that.
Okay.
The traditional way to add hydrogen involves this heated plasma.
Okay.
And while it works, it can really damage those NV centers.
It's like trying to fix a delicate watch with a hammer.
Yeah, kinda.
Okay, so they need to come up with a more refined approach.
Right.
Something that can delicately add this hydrogen layer without, destroying those quantum properties.
Exactly, and that's what our sources dive into next.
Okay.
They look at the search for these gentler, more precise methods for manipulating those diamond surfaces.
This is getting good. I can't wait to see what they came up with.
Yeah.
But before we get into all the details of these new methods,
Okay.
let's take a second to just process what we've learned so far.
All right.
We've gone from sparkling jewels to cutting-edge electronics.
Yeah,
We even went into the quantum realm.
it's been a journey.
It has.
It's amazing how much progress has been made in understanding and manipulating this material.
It is, and it's exciting because we're really just at the beginning.
Oh, yeah, this is just the start.
I'm ready for the next chapter in our diamond heist.
All right, let's do it.
Let's dive into those new hydrogenation methods and see how researchers are trying to protect those valuable quantum properties.
Let's go. Welcome back.
Okay, so where are we in our diamond heist? How do researchers plan to add that hydrogen layer without, messing up those NV centers?
Right. Well, they've been looking at two ways of doing this.
Okay.
One is called forming gas annealing,
Okay.
and the other is cold plasma termination.
Okay.
Both of these try to get that hydrogen layer, but without using that harsh heated plasma method.
So let's break it down. What's the difference between the two?
Well, forming gas annealing, it uses a mix of hydrogen and nitrogen gas,
Okay.
and it works really well,
Uh-huh.
but it's super sensitive to temperature and how pure everything is.
Okay.
Like even a tiny bit of oxygen can mess up the whole process.
So they have to be super careful.
Absolutely. Now, cold plasma termination.
Okay.
It uses a plasma, but at a much lower temperature.
Okay.
So it's much gentler on those NV centers. That sounds good.
It is a big plus.
But I'm guessing there's got to be a trade-off somewhere.
Yeah, you're right.
What is it?
With cold plasma termination, the hydrogen layer you get isn't as good quality as with the other methods.
Oh, so it's like precision and quality versus gentleness.
Exactly.
What a dilemma.
It is.
So how do they even figure out which one's the best way to go?
Well, they use something called photoluminescence spectroscopy.
Okay.
So they shine a green light on the diamond
Okay.
and see how it fluoresces.
Okay.
This tells them about the state of those NV centers.
So it's like they're checking up on the ND centers after each treatment.
Yeah, exactly.
Make sure they're doing okay.
And the results are really something.
What did they find?
Both forming gas annealing and cold plasma termination.
Uh,
They were able to keep those NV centers fluorescing,
okay.
even after doing the treatments multiple times.
Wow.
But that old heated plasma method,
Yeah.
it caused a big loss of fluorescence and it couldn't be reversed. So that's a pretty big difference.
It shows how important it is to find these gentler methods.
Right.
So does this mean we found the perfect solutions? Not quite.
Why not?
Remember that forming gas annealing?
Yeah.
It needs you to control the temperature and the purity perfectly,
Right.
which is hard to do all the time.
Okay.
And with cold plasma termination, you get a lower quality hydrogen layer.
Right.
And that could limit what we can use it for.
So there's no easy answer.
Nope.
It depends on what you need the diamond for.
It does. There's still a lot more research that needs to be done
Yeah.
to really fine-tune these methods
Okay.
and see what the long-term effects are.
But the results so far are promising.
They are very promising.
This is so exciting.
It is.
I mean, we're getting closer to actually using these quantum diamonds
Right.
to do real things.
To solve real-world problems.
But let's take a step back for a second.
Okay.
Why should our listeners even care about all of this?
That's a great question.
What does it mean for them?
Well, the implications are huge.
Okay.
And they go way beyond just making our electronics faster.
Okay, I'm listening. Paint me a picture of this diamond-powered future.
Okay, so imagine a world with electronics that are more sustainable
Uh-huh.
and use less energy.
That sounds good.
Yeah.
Yeah.
Diamonds are so good at conducting heat,
Right.
which means devices that use them wouldn't get as hot.
Yeah.
And they would need less energy to run.
So we could be using way less energy.
Potentially, yeah.
It's a big win for the planet.
Definitely.
What else?
The possibilities are endless.
Okay.
Think about diamond sensors in healthcare.
Okay.
Imagine being able to detect diseases earlier
Wow.
and more accurately.
That's incredible.
It is.
What about other fields?
Environmental monitoring.
Okay.
We could use diamond sensors to track pollution
Uh-huh.
and monitor climate change super precisely.
It's amazing that something as simple as a diamond could have such a big impact.
I know, right? It really shows the power of science
Yeah.
and working together
Collaboration. Yeah.
and thinking outside the box.
I love that. Okay, so let's talk more about those quantum diamond applications.
Okay.
We talked about sensors, but our sources go a little deeper.
They do. The NV centers are really versatile.
Okay.
They can be used to create these super sensitive magnetometers.
Magnetometers. They
Yeah.
measure magnetic fields, right?
Right. But imagine a magnetometer that can detect the magnetic field of a single neuron firing.
Whoa, hold on. Are we talking about reading minds with diamonds?
Not exactly mind reading,
Okay.
but it could help us understand how the brain works
Okay.
and maybe even diagnose neurological diseases.
That would be groundbreaking. Are there other applications for these magnetometers?
Definitely. They could totally change navigation
Ow.
by giving us super accurate positioning data,
Okay.
even in places where GPS doesn't work.
So Diamond-powered GPS that works everywhere?
Exactly.
Wow.
And that's not all.
What else?
They can also detect individual molecules.
What?
It
Okay. How would that be useful?
Well, that could revolutionize fields like drug discovery and medical diagnostics.
It sounds like these quantum diamonds are like the ultimate multi-tool.
They really are.
So what's stopping us from seeing all of this in the real world?
Well, as with any new technology,
Yeah.
there are still things to figure out.
Like what?
We need to make the fabrication process better
Okay.
and improve the sensors themselves.
Right.
And we also need to build the infrastructure to support using them everywhere.
I see. So it's not all figured out yet.
Not yet, but we're getting there.
It's still amazing to think about what we could do with these diamonds.
It is.
But let's come back to the research for a minute.
Okay.
Our sources mentioned something about custom diamond surfaces.
Right. Right.
What's that all about?
This is where things get even more interesting.
Okay.
Remember we talked about adding hydrogen to the diamond surface?
Right.
Well, what if we could add other things too?
Other elements.
Exactly. Imagine a diamond surface
Yeah.
that has specific areas where hydrogen is attached,
Uh-huh.
but other areas have other elements attached.
That sounds complicated.
It is.
Mm-hmm.
It's like building with atomic Legos.
Wow.
We can choose different elements and arrange them carefully
Okay.
to create a material with specific properties.
So we can make the diamond do exactly what we want it to do.
Right, we can tailor it for different applications.
Okay, I'm starting to see the possibilities here.
Me too.
We could have a whole bunch of different custom diamonds,
Yeah.
each one designed for a specific job.
Exactly. It opens up a whole new world for diamond technology.
This is getting pretty intense.
It is.
But let's take a minute to digest all of this.
Oh.
We've gone from heist metaphors to atomic Legos.
It's been a wild ride.
It has, but it's all in the name of understanding these amazing diamonds.
That's right, and there's still more to learn.
All right, well, I'm ready for the next part of this diamond adventure.
Let's do it.
We'll explore what the future holds for these custom diamond surfaces,
Okay.
and we'll look at the bigger picture of what this research means for the world.
Sounds good to me.
All right. Welcome back to our diamond heist adventure.
It's been quite a journey.
It has. We've uncovered some incredible things about these lab-grown diamonds, from how they could completely change electronics to their mind-blowing quantum abilities.
It's really amazing to think about how much potential this one material has to really shape the future.
Yeah, and it's fascinating to me how this research brings together so many different areas of science. We're talking plasma physics, material science, quantum mechanics.
It's a real melting pot of innovation.
It is. It's a perfect example of how progress often comes from combining different fields.
Right.
So as we wrap up our heist here, what's the biggest takeaway for our listeners?
Okay.
What does all this mean for the future?
Well, that's the big question, isn't it?
It is.
One of the most exciting things to me is the potential for a more sustainable future.
Okay, how so?
Well, diamonds are incredibly efficient at conducting heat.
Right.
That means we could have electronics that waste less energy, and that could significantly reduce their carbon footprint.
So we're talking about a world with gadgets that are more powerful, more efficient, And better for the environment.
Exactly.
All thanks to diamonds.
And it goes beyond gadgets, too.
Oh, yeah, like what?
Think about diamond sensors in healthcare.
Okay.
We might be able to detect diseases super early
Wow.
and really accurately.
That's incredible.
Yeah. Or even personalized medicine
Okay.
tailored to your specific genes.
That's like something straight out of science fiction.
It is, but it could be reality.
What about other areas?
What about environmental monitoring?
Okay.
We could use diamond sensors to track pollution and monitor climate change like we've never been able to before.
It's amazing to think that something as simple as a diamond could help us solve some of our biggest problems.
Right. It really shows the power of scientific research
Yeah.
and the importance of keeping an open mind.
Speaking of hidden potential,
Yeah.
we talked about these custom diamond surfaces.
Right.
Where researchers are experimenting with adding more than just hydrogen.
Uh-huh.
Can you tell us more about that?
Absolutely. Imagine a diamond surface where we can control exactly what's attached to it.
Okay.
Some areas could have hydrogen for conductivity.
Okay.
Others could have nitrogen for quantum sensing.
Uh-huh.
And then we could add other elements in between,
Wow.
each one chosen to enhance specific properties.
So it's like we're creating a custom toolbox at the atomic level,
Yeah, that's a great way to put it.
with each element serving a different purpose.
Exactly. And this ability to tailor the diamond surface
Yeah.
opens up so many possibilities.
Like what?
We could create diamonds that are specifically designed for certain tasks,
Okay.
like more sensitive sensors,
Yeah.
more efficient electronics,
Okay.
or even completely new applications we haven't even thought of yet.
So we could have designer diamonds, each one made for a specific mission?
Yeah, it's like a diamond for every occasion.
This is amazing, but is it all just theoretical?
Not at all. Researchers are already making progress.
Really?
They're using different techniques to arrange atoms on the diamond surface
Wow.
with incredible precision.
So they're basically painting with atoms.
Yeah, kinda.
That's amazing.
And they're using really powerful microscopes
Okay.
to make sure each atom is in the right place.
That's mind-blowing, the level of control they have at such a tiny scale.
It is. It really shows how far we've come in nanotechnology.
It does. So what would you say is the most important thing you want listeners to remember from this deep dive?
The key takeaway is that diamond,
Yeah.
this material we usually think of as being beautiful and luxurious,
Mm-hmm.
it actually has the potential to revolutionize technology.
It's a reminder that there's so much more to discover,
Absolutely.
even in things we think we already understand.
Right. So for our listeners who want to learn more about this research,
Yeah.
the scientific publications we talked about are a great place to start.
Okay. And we'll include links to those in the show notes.
Perfect. There are also some really good online resources,
Okay.
like websites and videos from research institutions and industry groups.
Fantastic. We'll include links to those as well. So as we wrap up this episode, I want to leave our listeners with this thought.
Okay.
If scientists can already do this much with diamond, imagine what the future holds.
Yeah, what other secrets are hidden inside this seemingly ordinary material?
The possibilities are truly endless.
They are. So keep asking questions.
Yeah.
Stay curious, and you never know what amazing discoveries you might make.
That's a perfect note to end on. Thank you for joining us on this deep dive into the world of low-temperature diamond growth and custom diamond surfaces.
It's been a pleasure.
Until next time, keep exploring.